The speeding motorcyclist sees a traffic jam ahead of him. He slows down to 36 km per hour. That is 36 kilometers per hour to meters per second is 36 into 5 by 18. That is 2, that is equal to 10 meters per second. He finds that the traffic has eased and a car moving ahead of him at 18 kilometers per hour. Then we can need to convert this one also to meters per second. 18 into 5 by 18, that is equal to 5 meters per second. Okay. He's honking at a frequency of 1392. That is the frequency F is equal to 1392 hertz. Given data. If the speed of the sound is 343 meters per second, that is equal to V is equal to 343 meters per second. The frequency of the honk as heard by him will be. At what frequency he can hear that honking sound. Okay. Then here if you are going to draw the diagram, one person is the observer here. This is the observer. Okay. And one car is moving. Okay. Can draw the diagram. The car. Okay. One car is moving in this direction with the VS. Okay. And I will honking, that sound he can hear it what frequency we need to find here. Since the car is moving in this direction. Then we know that from the Doppler effect, we can find the answer. That is F dash is equal to V plus V naught divided by V minus Vs into F. Since the vehicle is moving in this direction, that means vehicle is moving ahead, then the minus Vs will becomes plus. This minus will becomes plus here. Then by substituting the values, V is equal to 343 and V naught, that is observer, that is equal to 10 divided by, again V is equal to 343 plus Vs is equal to 5 into that frequency is given as 1392. Then this becomes 353 divided by 348 into 1392. If we can cancel this 348 and this one with 4 times, then 343 into 4. 300 into 4 times is 1400. 3 times is 4 is equal to 12. That is 1412 frequency. This is in terms of hertz. So 1412, option C is the right answer here.